Hi ladies, so I had a really interesting question from a student in class. So I want to give you a little bit of video about dilating parabolas. So we talked about the fact that parabolas have an interesting pattern, right? Their vertexes centered at 0, 0, and there's steps to them that if you memorize these patterns, you can quickly create your parabola function. So the patterns generally go up 1 over 1, and then the next pattern goes up 3 over 1. And what we find with quadratics is that the next consecutive point goes up by an odd factor each time. So this was up 1 over 1, this was up 3 over 1, the next one would be up 5 over 1, right? So instead of creating this table of values, you can use this pattern of odd up values, if you will, to be able to generate your function. Okay, so now how does that apply to your dilations and transformations? So let's look at an example, maybe a function that's f of x equals, we'll put a 2 in front of x minus 3 squared, maybe minus 4. Okay, so quite a few things going on here. It has been dilated by a factor of 2, and the vertex has been shifted to the right 3 and then down 4. So this vertex, I'm going to actually start with that. My vertex is shifted to the right 3 and then down 4. So in my graph, I'm going to go right 3 down 1, 2, 3, 4, and I'll put a point there. And now I'm going to dilate this function by a factor of 2. So you could create your table of values and multiply all your outputs by 2. Or what you could do is kind of generate your outputs from these steps. So normally I would be going up 1 over 1. Now I'm going to go up by 2 over by 1 in each direction because I'm dilating my steps by a factor of 2. And I'm going to do the same thing for the next one. I'm going to go up by 6 and then over by 1. Up by 6. 1, 2, 3, 4, 5, 6 over by 1. And then over here I'm going to go up by 6 over by 1. And that's kind of how the dilations work, is that you use this steepness, like this vertical change, to be able to figure out what the dilation looks like. Let's look at one that's actually compressed, because those kind of follow a little bit of a different, similar format, but a little bit of a different scenario. So let's look at a function. How about we'll actually reflect it, 1/2, negative 1/2 of maybe x minus, well, let's do a plus this time, plus 3 squared. And we won't give any vertical transformation to that. So my vertex has been shifted to the left 3, and then there's no vertical transformation, so, well, no vertical translation. So my vertex is going to start at negative 3, 0. So over on my graph, I'm going to put a point at negative 3, 0. And let's talk about how this negative 1/2 is going to affect it. So here are my steps that I would use: up 1 over 1 and then up 3 over 1. The over 1 never gets changed. It's really just the vertical piece that's going to be changed because it's a vertical dilation, right? In this case, it's specifically a vertical compression. So I'm going to compress my vertical steps by a factor of 1/2. So instead of going up 1 over 1, I'm actually going to go up by, well, not even up. I'm going to go down by 0.5 for every 1. And if you want to take a guess on this, I would go down by 1.5 for every 1. So here we go. So at my vertex, I'm no longer going up, I'm now going down, and I'm going to go down by 1/2 for every 1 in each one of these directions. And this is where the next step is going to feel interesting. From that point, I'm going to go down by 1.5 for every 1. So I'm going down by 1.5 for every 1. I'm going down by 1.5 for every 1. All right, so this is how we would dilate, either by compressing or by stretching our parabolas. Have a good one, girls.